6.4 is all about parallelograms that are more than just parallelograms. They actually are classified as shapes that make them more than that. So the three shapes we're going to look at are rhombuses, rectangles, and squares, which are all parallelograms, but knowing that they're a rhombus or a rectangle or a square tells us more information about them. It's a more specific classification. So what we're going to do is we're going to be putting a lot of information for each one. Okay, and then we'll fill in our front side. Okay, a rhombus, the definition of a rhombus is a parallelogram. Okay, so that means it's going to have all the properties of parallelograms. It's going to have opposite sides that are congruent, opposite angles are congruent, the diagonals will bisect each other, consecutive angles are going to be supplementary, okay, all that stuff. But it's a parallelogram with 4 congruent sides. Okay, so you get all the parallelogram properties, but you also get 4 congruent sides. In addition to this, you're going to get that the diagonals of a rhombus do a couple things. So if we just put our diagonals in here and start looking at what this is going to do for us. Okay, I know all these sides are congruent. Okay, because it's a rhombus. I know all these opposite sides are parallel because it's a parallelogram. Okay, I know the diagonals bisect each other because it's a parallelogram. Okay, so what I'm going to be able to get here okay, I'm going to have these vertical angles. And I'm going to have these vertical angles. Okay, so since these big angles are congruent and these triangles, all 4 of these triangles are going to be congruent. Okay, I don't even need these. So I've got this triangle here has a 2-line side, a 3-line side, and a 1-line side. This triangle has a 2-line side, a 3-line side, and a 1-line side. So all 4 of these triangles are congruent to each other. Okay, which means that all 4 of these angles in here are congruent. And if they're all congruent, that means that the 2 that are next to each other have to be 90 degrees. So I'm going to have 4 90-degree angles in the middle. So I get this property. The diagonals are perpendicular, okay, which means they make right angles when they meet each other. In addition to that, since these triangles are congruent, okay, if you look at the orientation, that would mean that these angles are congruent. These triangles are congruent, so these angles are going to be congruent. Same thing here. I can give these the same marks as I gave up here because opposite angles are congruent, and these can get the same. So the diagonals are also bisecting angles. Okay, the diagonals bisect a pair of opposite angles. Okay, and it turns out that all 3 of these are biconditional statements. Okay, so if we have a parallelogram with 4 congruent sides, then it's a rhombus. That means if we have a rhombus, it's a parallelogram with 4 congruent sides. So these are actually ways to prove that you have a rhombus also. So you have to start with parallelogram for each one of these. Okay, if you have a parallelogram, so if you prove something's a parallelogram and then you prove that the diagonals are perpendicular, then you can say it's a rhombus, which would give you all these other properties. So let's fill in our front page. Okay, so branching off from the parallelogram, we're going to go over here. Put rhombus for the shape down here. And here's the 3 ways to prove it. Okay, 4 congruent sides, perpendicular diagonals, or diagonals bisect angles. So once I have parallelogram and I get one of these 3 things, I then know it's a rhombus. Okay? The other thing that's going to come off of parallelogram is a rectangle. So let's look at that next. Okay, let's look at some properties of a rectangle. A rectangle is still a parallelogram, but more specifically, it's a parallelogram that has 4 congruent angles. Okay, so all 4 of these angles are congruent. We can get more specific than that, though. Okay, if all 4 of these angles are congruent, and I know they have to add up to 360, that means that all 4 would have to be right angles. And if I have one right angle in here, okay, if this is a right angle, remember this is a parallelogram, that would mean that this has to be a right angle because opposite angles are congruent. So if this is a right angle, that means this is a right angle because these have to be supplementary. So do these. So it's a parallelogram with a right angle. Okay, because if you have one right angle in a parallelogram, that means all of them are right angles. So we can put in parentheses under here 4 right angles. Okay, so that's one thing you're going to get. The other thing you're going to get, if I put a diagonal in here, that was not a very good diagonal. Okay, if I put a diagonal in here, I already know that these opposite sides are congruent. I know these are congruent. Okay, and I'm going to know that this is congruent to itself. So these triangles are going to be congruent. But if I put the other diagonal in also, okay, if I look at this red triangle here, okay, I'm going to have side, angle, side, okay, because it's got the right angle in the middle. And it's going to be side, angle, side with this triangle, this green one, okay, which means the diagonals, okay, the hypotenuses of the right triangles are congruent. What that really tells me is the diagonals are congruent in a rectangle. Okay, and this is how we're going to prove that a parallelogram is a rectangle. So let's fill this in on the front. Okay, so in order to go from parallelogram to a rectangle, I need one right angle or congruent diagonals. Now, if I can get both of these things, so if I get parallelogram and I know it's a rectangle, and I can also prove that's a rhombus, that makes it a square. Okay, so a square is both a rectangle and a rhombus and a parallelogram and a quadrilateral. So that's the last one we're going to look at here. A square. Okay, a square is a parallelogram with 4 congruent sides and 4 congruent angles. So what it really is a regular quadrilateral because it's equilateral and equiangular. Okay, square gets all the properties of the above shapes. So a square would have 4 congruent sides, perpendicular diagonals, Diagonals are going to bisect a pair of opposite angles. The diagonals are going to be congruent, and it's going to have 4 right angles. So square gets all of those properties. Okay, and the way you prove a square is by proving that it's both a rectangle and a rhombus. So let's look at some problems here. All right, the figure below is a parallelogram. What further classification can you give it? So let's look here. Based on what's marked, I can see that the diagonals are bisecting opposite angles. So that gives me rhombus. Okay, the diagonals are bisecting each other, but that's still just parallelogram. But I notice that all the pieces have the same marking. So this would be the length of 2 single marks. This would be the length of 2 single marks. So that's telling me that the diagonals are congruent, which gives me a rectangle. So in actuality, since this is a rhombus and a rectangle, this is a square. Okay, even though it doesn't look like it, it's got all the properties of a square. Figure below is a rectangle. Find the value of x and y. Well, rectangle, I know that these two opposite sides have to be congruent. Okay, so I'm going to get it 5x equals 15, so x equals 3. And it's a rectangle, so I know that 7y plus 6 has to be 90 degrees, because all the angles in a rectangle are 90 degrees. So minus 6, 7y equals 84, so y equals 12. What shape is PQRS? So we're going to use those distance formulas and the slopes again to figure out what this is. So let's see. Let's find PQ, the slope, and the distance here. Slope, I'm going to take 9 minus 2, which is 7. I'm going to take 1 minus 5, which is negative 4. The distance, 7 squared, is 49. 4 squared is 16. If I add those up, I get the square root of 67. Let's do QR. Slope is going to be 7 over, let's see, 7 over 1 minus negative 3 is 4. 7/4. Okay. And its distance is going to be the same as what I just had. So at this point, these are, because it's PQRS, PQRS, I've just found that 2 consecutive sides are congruent. Okay, so I'm leaning towards maybe a rhombus here, but I don't have enough information yet. Because first I need to know it's a parallelogram, and I don't have that. So let's do RS, slope. 2 minus negative 5 is 7. Negative 3 minus 1 is negative 4. So now I know that these are parallel. Okay, let's do distance. I'm going to get the same thing, square root of 67. So at this point I do know that it's a rhombus, because I've got one set of opposite sides that are both parallel and congruent. So I know that it's a parallelogram. And since this side is square root of 67, I already know that PS is also going to be the square root of 67, because parallelograms have opposite sides that are congruent. Okay, and opposite sides are going to be parallel, so I already know that this is going to be 7/4. So right now I just have parallelogram, or actually I have rhombus, okay, because I have all 4 sides congruent. Now I need to know if it's a rectangle. In order to be a rectangle, I need right angles here. So I'm going to look at 2 consecutive sides, so 2 sides that are touching, and see if these are perpendicular. They are not perpendicular, because in order to be perpendicular, the slope would have to be flipped and switched. So I have opposite signs, but I don't have reciprocal. So all I can say is this is a rhombus. I don't have enough to, in fact, I know it's not a rectangle, which means it cannot be a square.